In this video, we're going to work out a released AP free response question for particle movement. In this case, it's the 2011 Calc AB question number 1. Now, keep in mind, a question number 1 is a calculator problem. So you need to have your calculator with you, and so we're going to use that and kind of go through the steps of how to do this. So take a moment and read the question. Thank you for reading the question. So let's see, we have a velocity function has been given to us, an acceleration function has been given to us, and an initial position has been given to us. Definitely want to circle that initial position because we're going to be using that later on if we're trying to find position, and indeed down here we are trying to find position. This is over the time period from 0 to 6, so we're going to have to be mindful of that on our calculator. So let's look at part A. Is the speed of the particle increasing or decreasing at time 5.5? Well, we know that a particle will speed up if the signs for velocity and acceleration are the same. So that's going to give us speeding up. If velocity and acceleration are different, then that's going to slow down. So slows and speeds. So increasing, decreasing. So let's go ahead and start by finding the values for, in this case we want 5.5, so we want V of 5.5 and we want A of 5.5. Well, if we get out our calculator and we go to y equals, so we're going to turn it on and go to y equals, and we're going to type in the velocity function 2 sine of e. E is your second natural log key. Now I know it says t, but we can go ahead and just use x divided by 4. And we need to write it over to get out of the exponent, and then plus 1. Now it's really important that you double and triple check that you've typed this in correctly. Now if we start with a zoom 6, which is what I always suggest you do, because that's our default graph, we get the following graph. Now we don't want the entire graph, we're only caring about 0 to 6, so I would suggest at this point to go to your window. Your x min should become a 0, and your x max should become a 6, and then regraph. This will allow us to get a slightly better picture to work with. Now, what we're looking for is the velocity and the acceleration at time 5.5. Well, since this is a velocity function, if we go second trace button to our Calc menu, all we need to do is find the value at 5.5 for our velocity. So value is option 1, and we want x equals 5.5, and when we hit enter, that gives us our answer. So now when you do this, you want to copy down the entire decimal, and I'm going to forget this, so when I write this down, I'm going to have to look at it a couple of times. Negative 0.4533, so negative 0.4533, and then we've got a 701. So now, if acceleration is also negative, then the particle is speeding up. If acceleration is positive, then the particle is slowing down. Now, I know they provided us with the acceleration function, and we could do that separately, but our Calc menu will allow us to do the derivative of velocity, which is indeed acceleration. So now let's go back to our Calc menu. Second trace is Calc. We look down our options, and option 6 is a derivative, which would give us acceleration. Now again, we want 5.5. This time, the calculator does not prompt you with an x equals. You simply need to know to type 5.5. Once you type the 5.5, the x equal comes up, hit enter, and again, copy down that entire decimal. And I'm going to forget again, negative 1.358, negative 1.358, and that's going to give us then a 511. All right, so we've got our two decimal values. They are both negative. So when we answer the question, we would say that the particle speeds up because, and now we can either write the words that velocity and acceleration are both negative at 5.5, or we could say v of 5.5 is less than 0, a of 5.5 is less than 0, and then note that same will speed up. The more words you use, the better off for them, so it would be good to use complete sentences. So that would be part A. Let's go ahead and clear all this work out and look at part B. So in part B, clear out. Okay, maybe it won't clear out. So let's go ahead and see what we can do about just erasing it. So in part B, we're looking at find the average velocity of the particle for the time period 0 to 6. Well, so when you see the word average, most of the time, we're going to be following a particular formula, and average velocity is definitely that formula, which would be 1 over b minus a integral a to b of the velocity function dt. Now, if you think about it, when you're finding an average, what you're doing is you're adding up all of the numbers that you need and then dividing by how many numbers there are. Well, if you haven't figured it out yet, integration is addition. It is a sum. It is the sum of all the areas, an infinite number of areas, under the curve over the time interval. So if we take the sum of all the area and then divide it by the time interval, in this case 1 over b minus a or 1 over 6 minus 0, that would give us average velocity. So what we want is we want 1 over 6 minus 0 integral 0 to 6 of the velocity function dt. Well, we could use Math 9 to do this, and that is one option. A second option, since we already have the graph, is we could use the graph to find the integral and then simply divide by 6. So if we go to our Calc menu again, now we've got option 7 is our integral. It's going to ask for our lower limit, which was 0, so 0, enter. Our upper limit is 6, so 6, enter. And it's going to shade the area under the curve and give us a value, in this case 11.69628. I would write that value down, 11.69628. 11.69628. And we're going to put that down there as our value, but then we're going to have to divide that by a 6. So since we already have that value up there, all we need to do is hit the divide by button. It'll bring the answer down. We're dividing by 6, and we get 1.949380033. I would again write that entire value, 1.949, 1.949, 380033. Now, you can get away with rounding to the thousandths place, but I think it's safer simply to write the entire decimal. Let's go ahead and get rid of this work now and go down to part C. In part C, we want to find the total distance traveled by the particle from time t is 0 to t is 6. Well, so total distance traveled means we need to make all of the area positive. So we can go ahead and integrate from 0 to 6 of the absolute value of our velocity function dt. Now for this one, I think I'm going to go ahead and use Math 9. So I'm going to go ahead and clear this out, and I'm going to go to Math 9. And we know we're going from 0 to 6. We want absolute value bars, so that's going to be the Math button, right arrow once, option 1. And now we're typing in our velocity function. Our velocity function, again, be careful how you type, garbage in, garbage out. So 2 sine e to the x divided by 4, and then we need to right arrow over to get out of the exponent to put our parentheses. Then we have a plus 1, and for some reason, students will frequently miss that plus 1 because they get all caught up with the parentheses. So be careful about that. You have to put in your dx, and then go ahead and hit enter. And it'll think a little bit for a while because of the absolute value bars. Don't panic. Go ahead and give it some time, and you'll get your value. So when you're writing this out, you need to show your integral and then put ahead your answer. So that's 12.573, 12.573, 26231, 26231. Showing this part is vital, and then of course you're going to want to put your answer. This last part, part D, and let's go ahead and get rid of this work so that we've got some space. They're asking two things. First, they say that the particle changes direction exactly once over this interval. So we're going to want to find that first. So go ahead and go back to your graph, and we want to find the 0. Now if I just kind of sketch this over here briefly, our picture is looking like this. So we're looking for the 0, the x-intercept. So in order to do that, again, we're going to return back to our Calc menu, and option 2 is 0. Now, your calculator will prompt left bound. Now, there's a flashing cursor that is on your curve, and you're going to want to get that flashing cursor to the left of that 0. So if I can show it over here, you want to be to the left. Notice there's your 0, anything to the left. Once you do that, you can go ahead and hit enter, and it's going to prompt you for a right bound, so you'll want to move your cursor to the right, anywhere to the right, so somewhere over here to the right, and then again, go ahead and press enter. It asks you to guess. We don't want to guess. Hit enter one more time, and it will give you the value, the x value of that intercept. Now you're going to want to use the entire value again, so let's copy that down, 5.1955, 5.1955. If you don't use the entire value, you're going to have error, and you're probably going to get the wrong answer. 223 is your x value. Now notice the second part of the problem says find the position of the particle at that time. Well, when you're doing this, you need to be mindful of your initial position, and it's always located at the end of that first paragraph. So we're starting at 2, so let's go ahead and put our 2, and then we're going to add to that our distance traveled. So our distance traveled from 0 to 5.1955,223. Now this is net distance, so we're just integrating velocity dt. Well, so let's go ahead and take a look at that. Now we've got a couple of choices. We can do this with our Math 9, or we can do this with the graph. Since I already have the graph up, I think I'll use that. So I want to do second Calc, option 7. I'm again integrating from 0. This time, my upper limit is that big long decimal, 5.1955,223. So I integrate that part, and it'll take a little bit to think about that. We get 12.13477. So 12.13477, 12.13477, and we're going to add 2 to that. So when we add 2 to that, again, we can simply go plus 2, enter, and we get 14.1347739. Again, I would use that entire decimal. So I've got 14.13477 is the position of the particle. Now if we take a quick look at how AP will grade this, it's worth 9 points. You get 2 points for part A, conclusion and reason. So you're going to want to show your decimal values, write a sentence for why things happen. In part B, 1 point for the integral and 1 point for the answer. So the integral would be that piece, but then knowing to divide by 6 because it's an average gets you the answer. In part C, 1 point for the integral, 1 point for the answer. So knowing what to put gets you a point, and then actually typing it in correctly will get you your second point. Finally, in part D, considering V is equal to 0, which would be stating that and then finding our value. Then we need the integral. Then we finally need the answer, and the key to the answer is remembering to add that initial position.